The lesson outcome for this video is I can graph exponential decay. Now, exponential decay is actually very much the same as exponential growth, except for instead of something growing at a certain percentage rate, now it is decreasing at a certain percentage. Notice that I use the exact same model here, y equals a times the quantity 1 plus r raised to the t power, the same model as I did with growth. The difference is going to be that our rate is going to be negative, and that's because we're decreasing the amount of whatever we have. So if you think about 1 plus r, remember we talked about that as being another way of talking about b. So let me write this up here. Y equals a times b to the t power. Okay, so remember b is our growth factor, and in this case it's going to be decay. Sorry, that's a b up there. B is another name for 1 plus r. Okay? Now if our rate is negative, so let's say something's decreasing by 75%. Okay, let's say something is decreasing by 75% every hour or something like that. Well, that means that it's decreasing by 75%, so that's going to be negative 75%. So if we were to put that in here as a decimal, it'd be you could say plus a negative or minus. So either way you want to think about it, minus the 0.75. Remember, we use a decimal format of the percent. So 1 minus 0.75. Well, 1 minus 0.75 is 0.25. That's where I get this 0.25 down here. So notice I say right here, the value of b, which is this value right here, which is also shown as 1 plus r, is always going to be between 0 and 1. Now, many times people think this number is going to be negative. That number is not going to be negative. The r value is negative, but we have to do 1 minus that r value, which will mean that this will always be between 0 and 1, a decimal or a fraction. So in this case, 0.25. So let's just take a look at this equation right here, y equals 2 times the 0.25 raised to the 10th power. What this is an example of is that there is an original amount of 2, let's say $2 in your checking account, and let's say 10 is our time, so number of days or years or whatever that are going to go by, and then this 0.25 means that it is decreasing because it's between 0 and 1, it's not greater than 1, so it's decreasing at a 75% rate, because again we subtracted that 75 up here, that 0.75 from 1, which is why we have 0.25. Again, this will make more sense kind of as we go along. Okay, so let's take a look at another example of exponential decay. If you look at the equation y equals 1/4 raised to the x power, I just want to think for a little bit here with you about what each of our values in our equation or model represent. Okay, so we have our original amount, remember, is the number that's in front of the base that's raised to the exponent. Well, what number is out here in front of our base, 1/4, that's raised to our exponent? Well, there's no number out here, which means that that number is 1, just to remind you about that. So it's like our original amount is 1. All right, so then our b value, which is another name for 1 plus r, is 1/4. Now, since that is not greater than 1, we know that our 1 plus r, okay, if r is greater than 1, if r is a positive number greater than 1, this will be 1 plus something that's greater than 1, which means it will always be greater than 1 as a whole factor. Since this is not greater than 1 inside the parentheses, we know that it is a decay situation, okay? So it is decaying. And that's all we need to know about that at this point. And we'll get more in depth on that when we get to our word problems and when we're calculating our exponential decay. But for right now, let's go ahead and graph this. Now we're going to do the same steps as we did in growth. So first thing I'm going to do is I'm going to take y equals 1/4, and I'm going to raise that to the x power. In this case, x is -2. So I'm going to raise it to the -2 power. Okay. Now when we do that, remember we're dealing with negative exponents again. So we have let's take this 1/4 and say it's all being raised to the -2. So let's think back on our power rules for a minute, and then we will be able to compute this with our with our calculator. So 1/4 raised to the -2 means that 1 is being raised to the -2 and 4 is being raised to the -2. Remember, that is a power of a quotient. Well, we also remember that a negative exponent means we need to move it and make the power positive. So I'm going to move the 1 to the -2, I'm going to move it to the bottom, and I'm going to make the power positive, so 1 squared. And I'm also going to move the 4 that has a negative exponent, I'm going to move that to the top and make the power positive. So now we have 4 squared, which is 16, over 1 squared, which is 1. So we have 16 over 1, which is just 16. All right, let's do our second one. Y equals 1/4 raised to the -1. So we have 1/4. We're going to raise that to the -1, which is 1 to the -1 over 4 to the -1. 1 to the -1, we're going to move it, make the power positive, and 4 to the -1, we're going to move it and make the power positive, and that will be 4 over 1, or 4. Okay, now the next ones will be a little bit easier because we're not raising them to the negative values. So y equals 1/4 to the 0. What's anything raised to the 0? It is 1, the number 1. And now we've got y equals 1/4 to the first power. Well, 1/4 to the first power is 1/4, and 1/4 can be written as a decimal if you'd prefer, which is 0.25. And then lastly, we have y equals 1/4 to the second power. So 1/4 to the second power, again, the same power of a quotient rule works here. We have to square 1 and we have to square 4. 1 times 1 is 1, and 4 times itself, 4 times 4 is 16. So it's 1/16. And 1/16, if you want to write that as a decimal, is 0.063 if we round that to 3 decimal places, or it's 0.0625. Okay, so now we're going to go ahead and graph those points. We've got -2/16. Now that's not quite on the graph. I'll try to kind of squeeze it in where it belongs. Oops, sorry, not there. All right, so -2/16. -2/16 is probably right up here. Then we have -1/4. -1/4 is right here. Then we've got 0/1. Whoops, again. 0/1 is right here. 1.25, well, 1.25. So we're going to go over 1 on the x-axis, and we have to go up 0.25, which would be 1/4 of the way to 1. So right there. And then we have 2, 0, or 0.0625, which is practically on the x-axis, but not quite to it. So there's our curve. We're going to go ahead and draw the line here. Or, excuse me, draw the curve. And notice I'm not going to cross over the x-axis because this will never cross over the x-axis. So here is the graph of our exponential decay situation, and again, it's kind of similar to exponential growth, that growth starts off slowly, like let's say doubling, and then it grows exponentially fast, as we say, because the doubling process makes it increase at a large rate then. Whereas with exponential decay, this original first few data points are decreasing very, very fast, but then the decreasing kind of slows itself down a little bit. Okay, so let's try this one. It's a little different because we have a value other than 1 out in front of the 1/3. So it just takes a little bit more work in simplifying in our table. So let's go ahead and start with -1 for our x value. So y equals 3 times 1/3 raised to the -1. All right, so let's go back to that 1/3 to the -1 situation. That means 1 is raised to the negative 1 and 3 is raised to the negative 1. We need to move it and make the power positive, so 1 to the first and 3 to the first, which will become 3. 3 over 1 is 3. So now this part right here becomes the number 3, is the number 3, I should say. And so 3 times 3 is 9. All right, let's do our next one. Y equals 3 times 1/3 raised to the 0. All right, so what is 1/3 raised to the 0 power? Well, anything raised to the 0 power is 1. So we have 3 times 1, which will be 3. Our next one, y equals 3 times 1/3 raised to the first power. Well, 1/3 of the first power is 1/3. So this is just 1/3. And then 3 times 1/3. Well, 3 times 1/3, if you think about 3 being the same as 3 over 1, what happens here is our 3 over 3 can be simplified. So 3 divided by 3 is 1, so this all becomes 1 times 1 over 1 times 1, which is 1. In other words, 1/3 of 3 is 1. And now we've got y equals 3 times 1/3 raised to the, raised to the second power. Okay, so 1/3 raised to the second power is going to be 1 squared over 3 squared, which is 1 times 1, which is 1, over 3 times 3, which is 9. So we've got 1/9. Now we have to do 3 times 1/9. So 3 times 1/9, again this is 3 over 1 is another way of looking at that. So if I divide this by 3 I get 1, and if I divide this by 3 I get 3. So what I get is 1 over 3 when I multiply them. So 1/3 is 0.333. And now we're going to plot our points. All right, so the first point is -1, 9. So -1, 9 is here. Our next point is 0, 3. 0, 3 is right here. And 1, 1 is right here. And lastly, we have 2, 0.333, which is 1/3 of the way up to 1, which is right about there. And again, we can graph that curve like so. And again, we do not want to cross over that x-axis. It kind of looks like it is, and I'll talk more about that, about why it will not cross over the x-axis in class and with our word problems on the next lesson.